All right, Sarah Wynn here with the Downtime, here with Festo's Tom Worsnopp. Tom, welcome to the show.
Thank you. Good to join you.
It's a pleasure. I'm so excited for this conversation. Can you tell us a little bit more about yourself and your work with Festo?
Yeah, absolutely. So as you said, my name is Tom Worsnopp. I am a product market manager for Festo North America. I handle our servo drives, motors, and electromechanical actuators. Let's see, I've been with Festo now coming up on 15 years, and I am based in the Northeast.
Tom is here today. We're going to talk about the new servo drive Festo recent release, the CMMT-AS series. Tom, do you want to
Yes.
just tell us a little bit about it before we get rocking into our questions?
Yes, absolutely. So we have had the CMMT-AS series, actually the CMMT series. There's another uh, s- type of drive in the series, but the AS part of that for we're coming up on 8 years. We're coming up on 8 years, and the we cover a range in the series. This is our AC servo drive product line, and we go from a low of 350 watts up to 12 kilowatts. So we can do a huge range of industrial applications with these. We support multi-protocol field bus, which means that you don't have to select which field bus ahead of ordering the product. You just configure it when you are using it. Um, and so well, do you want to introduce the topic? The topic is
Go
advanced
for it.
safety, right?
Yeah.
So this entire series has had safety functionality since its release. So we've always had safe torque off, safe brake control, and safe stop one. And these are just standard safety features in the industry. So I'm not going to define them here, but if you're watching this podcast, hopefully that means you're interested in servo drive safety. And so those functions were in the series already, and they still are. They're going to remain in the series. We've released a new drive, which we were designating the S3 version. The original was the S1 version, and that just refers to the degree of safety that we're offering with those servo drives. And so the S3, we add new hardware, so it's a separate series, but it exactly mirrors the current series. So if you order, from the smallest drive all the way to the largest drive, we now offer that with additional safety functions.
Okay.
And I can go deeper on that if
Yeah,
you want to do
let's
that now,
let's talk
or
additional safety. Let's go for it. Let's do it.
okay. So there's two parts of this. There's what additional safety functions you get when you switch from the S1 to the S3. And that includes things like safe limited speed, safe stop 2, safe operating stop. Um, I'm missing one off the top of my head, but we have them in the catalog. And then the other side of this, in addition to the safety functions, is now you can decide whether or not you're going to use digital I/O, which the S1 drives, the basic safety that we offer, those were always just digital I/O, meaning you would have digital inputs into the drive. When you drop those signals low, the safety function would trigger. So that still exists in the S3. So it's just different safety functions. So, if you wanted to trigger safe limited speed, for example, you would just have two digital inputs and, two redundant signals. If one or both of those drop, the drive implements safe limited speed, and now you're limiting the speed of that motor, right? The other way is to use field bus over safety over field bus, right? And there's different versions of this depending on which manufacturer you're using for your controller. So, for example, if you're using Siemens, then they offer ProfiSafe as their safety over field bus option. And if you're doing Rockwell, then they've got SIP safety. And then if you're doing an EtherCAT based one, it's typically functional safety over EtherCAT, which is FSOE. With this first release, which just happened a few months ago, we are introducing it with ProfiSafe first, and then in the future we will add additional safety field buses. So from the get-go, you can do digital I/O, that's any
Mm,
controller, or ProfiSafe, which allows us to work with anyone who's doing a Siemens controller.
okay. Um, do we are there hardwired options as well?
Yes, that's the digital input option.
Got it.
That is the hardwired option. So that means anybody who wants to do safety using the the new drives, they just
Mhm.
have to wire some inputs into the drive, can try that tie that back through their safety relay or their safety controller, and that gets implemented. That simply. It's really that simple. If it is on the safety field bus side, now they have to have a special safety controller from, well, in this case, I'm saying Siemens for
Mhm.
ProSafe, and that typically costs more. It means they have to know how to program it. So there's a little added work there for the programmer, but it simplifies things, right? You don't have to wire anything anymore. You're doing everything over field bus. So, once you understand how to do that in the Siemens architecture, it's actually very easy to implement because you're literally just plugging an Ethernet cable into the device.
Yeah, you mentioned Siemens. I'm guessing you work with other controllers as well. Yes.
Correct, yes. So
Mhm.
the CMMT series of server drives that we offer, they're multi-protocol. And so that means you can configure it for Ethernet IP, for EtherCAT, for Profinet, and even for Modbus TCP, which is a little more obscure. Um, and so as of right now, if you were to buy this S3 drive, you can use it with any of those protocols, but if you
Mhm.
want to do SIP safety, we don't support that yet, right? That's the Ethernet IP based safety field bus.
So you mentioned this series existed before, and the newest edition is the security layer. What inspired adding more integrated security into this drive?
Okay. So yeah, let me just frame that slightly more. So on the S1 version of the drive right now, when you connect to the device, there's no login essentially. You can just go online with it and change the configuration. With the new S3 drive, and kind of any safety device, you don't want somebody to be able to log into it with any kind of password or anything and modify parameters because that means what safety circuit or safety function, that's a better term, you've set up in there could potentially just be changed by anyone who has an Ethernet cable and the software to configure the CMMT. So that's the primary reason for this.
Mhm.
There is a secondary reason that's lurking in the back for every manufacturer of servo drives as well as other electronics, which is the Cyber Resiliency Act, which is you're familiar with it. It is a European base, so this only affects European manufacturer. Well, it affects everyone who sells into Europe. So actually, it affects every manufacturer because most manufacturers of servo drives are trying to sell globally. But you have to create some measure of cyber resiliency, which in most cases means having login requirements. So this is actually, we were going to do this anyway for the safety drive because you don't want people able to change the configuration, but this is a step towards putting login requirements and extra security on every device because we have to in order to comply with this new Cyber Resiliency Act, which is, the goal there is to make it much harder for hackers to mess up a machine, essentially.
Just wondering, is there a
Mhm.
remote management aspect to this too? Is how does Festo approach that?
So with any device that can connect um, to the internet, I mean, it's not the internet. Most machines you don't put them online because it
Mhm.
increases the risk, but you can because as long as they have, you know, an RJ45 connection for Ethernet, they can be connected, and then you can absolutely do remote configurations. You can do all that. Um, Once you do, in the current scheme, device requirements for security are still lower. And
Mhm.
that's what the Cyber Resiliency Act is going to do. It'll raise the bar so that every device on your machine also needs additional security. So yes, your original question, any of these devices can be modified remotely if the customer sets up the machine to connect to the internet. Then, it's just a question of logging through their firewall on the machine and then into the device with the password.
Let's
Yep.
talk about the new series. How does the S3 change machine design and or integration for OEMs?
So more and more frequently, we are getting requests from machine builders that they need, well, one of two things is the primary driver. Either safety over field bus, right? So it could be they're using a very simple safety function like safe torque off, which just kills the power to the motor.
Mhm.
Very standard. You at least want to make sure that when an operator is cleaning a machine, you can specify there's no power on the motor, so it is safe for this application. More and more frequently, customers asking us for, oh, I do need something that's more than just safe stop one functionality. I do need something that's a more active safety function because the safety level I'm implementing requires it, right? So one of these things that you see all the time at trade shows is the implementation of safe limit speed, where you'll get close to a big robot that's moving and it slows down, right? And they're almost certainly implementing some version of safe limited speed where they say, okay, we're monitoring all the speed of all the axes on this robot, and we're making sure that it doesn't go above a certain speed while somebody's within this zone or inside the cage or what have you. And that way it's considered safe, based on the risk analysis that they've done of that machine.
Got it. And then, do you have any real world examples? And I know you shared the trade show example, but maybe uh, with the servo drive being implemented into machines.
Okay, yeah, I can think of one. So, like, there are a lot of cases where you've got a user, they have to reach through a light curtain, they're putting something into the machine. And in cases like that, you know, if you don't have more advanced safety functions like safe limited speed, well, your choices are you either have to create space in the machine so that that person can't be harmed in any way, right? There's nothing immediately near that thing they're putting in. Or if you want to make a more compact machine, then in that section where they're breaking the light curtain and they're going into the machine, things slow down. So there's no chance that they could get struck by something while their hands are in the machine. So we've seen customers implementing that style of um, that use of the safety function where, okay, we're going through a light curtain, um, and so we want to slow things down, right? Um, we've also seen customers go the other way where they're like, well, we don't need that advanced safety. We have enough distance here. When somebody's putting this in, they're placing it onto a conveyor. It's basically safe. They can just put it there and it's moving into the machine. So, these are all valid ways to
Yeah.
do a machine, build a machine.
Oh, I love it. I love to hear the different examples. Thank you. I know we talked about it at the top, but let's circle back to password protected setups. Let's talk,
Yep.
how does it help with compliance and traceability?
So okay, so this goes into what a safety engineer is doing for a machine builder, right? So as the supplier, we're responsible for providing the device that is going to meet the safety level that the safety engineer specifies, right? So if they say, oh, we need performance level E, Cat 4, these are the safety
Mm.
requirements that the safety engineer is saying the machine needs from our device. So that's our responsibility. We have to make sure our device meets that. On the machine level, the safety engineer is concerned about, does this entire machine, can I certify it as a safe machine, right? And so part of that is that the device, we need to be able to provide that safety engineer with essentially some form of documentation or some way of measuring that the safety functions have been met. So there's two aspects to this. One is just the server drive itself um, that we're providing. It is able to provide information like you can do a trace function, right? So if you have um, let's say a safe stop one requirement or safe stop two requirement, there's a controlled deceleration that has to happen, right? So an example would be the operator opens the gate. You want everything, on that, let's simplify it, one axis. You want that axis to come to a stop very quickly, right? So it's no threat to the operator. That controlled deceleration, there's a time it has to take place in, right? In order for it to be considered safe. If it takes too long, then maybe the operator can reach the axis before it has come to a stop. And so the ability to trace that and see, oh, are we reaching that time? So you trace it, you say, okay, I'm able to do this controlled deceleration. I'm able to achieve it in 300 milliseconds. So as the safety engineer, that's safe. And our drive lets them capture that trace, and then they can take that trace and use it in their safety certification documentation, right? So that's the tie in there. Um, we're also going to go a step further. So in the software, we have implemented a what are we calling it? A safety wizard, which is a basically it automates this documentation portion of it, where now you finish doing the setup, right? The safety engineer tests everything. Okay, this is good to go. Okay, run the safety wizard. It now creates the documentation that does the trace for you. Just all the steps that you might need, and it pulls it all together into a safety report. And so now it just simplifies the process. So that's in the software right now. We are waiting on a certification. Actually, by the time this goes live, that may already be out. So, but that safety wizard is part of that whole documentation phase. It makes it much easier. You can do everything you need safety wise. You can do all the safety functions, and you can document it, but it's more of a manual process.
Mm.
And so we're going to take it to the next step and make it easier with that safety wizard.
Yeah. Who doesn't want a wizard helping them out?
And it's true.
Yeah.
It's true. We're very, we're so trained. Where'd my phone go? Oh, I'm using it for time record. I was gonna pick it up and show you. Like we're so trained for ease of use because it's like we're always holding these devices, and it's like if something isn't really easy, you know, we're like, well, why isn't it easier? It's sort of
Mhm.
natural for us to be used to things being convenient.
One question for you, Tom, and then I'll leave the floor to you. 2026, it's here. What is your vision for drive integrated safety in the new year?
Well, okay, so there's we're talking market. I'm assuming I'm going to be a little selfish and say for Festo, it's really about promoting these drives. It's about, getting customers aware that we offer these safety functions now and that we can do it over ProfiSafe or digital IO. If you're talking more broadly, the servo drive safety function aspect of this is actually pretty mature. Like these safety functions have existed, um, conceptually at least, for at least a decade, I want to say.
Mhm.
Um, and so I don't actually expect to see like some new innovation in the safety function part of this, right? Those exist, and server drive manufacturers, we implement them or we don't, depending on what our customers need. So that piece of it is really just, well, who's offering what, and nothing amazing new in that regard. Um, there's looming over everyone's, I think, questions when it comes to, well, what's coming is AI. Is
Mhm.
there a role for AI to play in these sorts of things? And it's a good question, right? Because, right, what's the sort of the heart of AI is it's very good at data, sort of, what's the right word? Pulling data together essentially and giving you like these are the patterns in the data essentially.
Mhm.
That's sort of a good way to think about AI, or how I like to think about AI. Um, and so then the question is, well, can that be applied to safety, right? And this is where I personally pause because the thing you want with safety is deterministic and reliable, right? Um, and that's in contrast to AI, which is often not deterministic and also not 100% reliable, right? It's getting better. Definitely getting better. But you've got things like, well, it's still getting these wrong, right? And this is just a simple query on the internet, and I ask it something, and it very confidently tells me something, and I know that's wrong. And so what you can't have that in a safety system, right?
Mhm.
So maybe there's something on the back end of safety where AI can be used to maybe simplify the way people interact with it. But on the actual implementation of safety, and I'm the one bringing this up, but it's just there in all our minds right now. I think it's, well, can we do more with AI for this? And it's like, you know, for the actual implementation, I'm not so sure. For
Mhm.
maybe on the back end of things, that could be interesting.
Mhm.
In 2026, though, I don't know. I mean, the AI stuff is happening very fast, so we'll see what comes of that. But um, that's where my mind goes when I think of, okay, what's coming in the near term.
AI is impacting everything.
Yeah.
So yeah, it is interesting to hear it in terms of servo drives. Uh, I'll leave the floor to you. Is there anything else you may want to add about Festo and working with machine builders or OEMs before we wrap up?
I mean, I can make the pitch. For anyone who doesn't know, Festo is an automation supplier. Maybe I should have led with that at the top, actually. But yeah, anyway, I mean, we're known very prominently as a pneumatic supplier, but we have been doing electric automation, so motion control, servo drives, um, electric actuators. We've been doing those for decades as well, and we're just getting further and further in the direction um, of these the pieces, all the pieces that connect to the field bus, essentially. We're doing more and more of that, right? So if you think about the remote, the pneumatic side of it, the pieces that connect us back, all the information back to your PLC, that's remote I/O, right? We're doing extensive remote I/O product development, and we have an extensive product line. On the servo drive and electric actuator side, we are I mean, like for electromechanical actuators, we have one of the biggest range of products that's on the market. And then on the servo drive side, we're one of the few manufacturers that covers the spread of, okay, if you're buying the electromechanical actuator, well, we make it very easy to integrate it with our servo drive and motor because we offer both the servo drive and motor and the actuator, which is not true for, many other suppliers that are in the industrial automation space. So, I think we occupy a pretty unique place in industrial automation, and we continue to push and grow what we can offer customers to help them um, automate their machines.
Yeah, awesome. Well, Tom, I hope to talk to you more in 2026. This has been a great
Yeah,
conversation. I appreciate your
I
time.
agree. Thank you.